Hey guys, Mr. G here coming at you with another math lesson. Math lesson number 3 in our division mini unit. Let's jump right in. Today, as always, you will need a piece of paper. Probably a lot of pieces of paper. We're doing a lot of great work. Leave yourself plenty of room. And a pencil with an eraser, a working eraser, a eraser that works well. So you can erase mistakes, fix them. That's the way to develop your math brain. What we're working on, our learning targets for this unit is I can find quotients with remainders of division problems with single-digit divisors and dividends to the thousands place. How we do that? Again, I can determine quotients with remainders using standard form or partial quotient strategy. So either of those strategies is what we're working on. Either or. And lastly, this week, our Yearn to Learn focus is be resilient. What does it mean to be resilient? Being resilient means you're able to continue working when things get tough, okay? Not everyone learns at the same pace. Things right now are challenging, not only with the curriculum, but staying at home, all the new changes. Continue to keep working, stay focused, yearn to learn. All right, guys, the first step to our lessons and our learning model, the I do. So, the I do, once again, you're focusing on my instruction. Now this stuff, not that it was before, is not new. So it really acts as review. So it's very, very important that your focus is completely on my instruction to follow along, get your brain engaged, get your brain remembering the skills, and that you're not distracted from things in your environment. So if you have headphones, put them on. Don't fidget with materials. Don't click on a new tab and start up YouTube. I know you already got into YouTube for the video. Don't be surfing videos. Focus on the I do. The I do is going to be short and sweet today. Let's start off with standard form. Before I do anything, we need to review the steps. Couldn't find my marker. It was right in my pocket. Say them with me. Divide, multiply, subtract, bring it on down, and bring it on back. Let's get my thought bubble in here. Okay, here's our problem. Let's go. 7,453 divided by a 6. I'm going to start in the thousands place. My greatest place value is where I'm going to start. So in my brain, I'm starting on my first step. So in my brain, I'm dividing. I'm thinking, can 6 go into 7? The answer is yes. 7 is bigger than 6. So I'm thinking about how many times 6 can go into 7, or how many times 6 can go into 7,000. When I do that, I use inverse operations. 6 times what number is going to give me 7 or close to it? Everyone should be thinking in their brains, Mr. G, that's easy. 6 times 1 is 6. That's only 1 less than 7. It goes in 1 time. I divided. I need to multiply. 6 times 1 is 6. I now need to subtract. 7 minus 6 is going to give me 1. I subtracted. Bring it on down. Bring it on down this 4. And bring it on back. I'm now going to divide 6 into 14. But is it 14, guys? No, it's not. It's actually 1,400 because I regrouped. I found out that 6 goes into 7,000 6,000 times. We just don't write the zeros in standard form. So I'm dividing. Can 6 go into 14? So in my brain, I'm thinking 6 times what number is going to give me 14 or close to it? I could skip count, I could grab my place value chart, or I just know. I know that 6 times 2 will give me 12, and I know that 6 times 3 will give me 18. 18 is too big. It's bigger than 14. So I know 6 can go into 12 2 times. Excuse me. I know that 6 can go into 14 2 times. Next step, I divided. I divided 6 into 14. I got 2 using inverse operations strategy in my mental math brain. I multiplied. 6 times 2 we know is 12. We just did that. So actually we're subtracting 1,200 from 1,400. I subtract. We're subtracting. 2 minus 4 is 2. 1 minus 1 is nothing. Nothing. I bring it on down. I now need to bring down my tens. I bring down that 5. I then bring it on back. So now I'm dividing. I am dividing 6 into 25. Is it really 25? No, it is not. It's 250. How many times can 6 go into 250? So, in my brain, I am thinking 6 times what number will give me 25 or close to it? I could skip count by 6s. I could look at my place value chart. I could just know it. I know that 6 times 5 is 30. That's too much. So 6 times 4 would be 24. 6 can go on to 25 4 times. I divided. I now need to multiply. 6 times 4 is 24. We just discussed that. I now subtract. I multiplied. Now I must subtract. 25 minus 24, or 250 minus 240 is going to give me 4 minus 5 is 1, 2 minus 2 is nothing. Let's move this thing. That's going to get in the way. Okay, so I have 1. 4 minus 5 is 1, 2 minus 2 is nothing. I subtracted. I need to bring on down. I need to bring down my 1s. I need to bring down my 3. I now bring it on back. I now have 13. I have 13 1s I've regrouped. I need to divide 6 now into 13. So, in my brain, I'm thinking, how many times does 6 go into 13? I'm also thinking, 6 times what number is going to give me 13 or close to it? Okay, I skip count. I use a place value chart. I do something. I use a strategy. I know that 6 times 2 is 12. That is really close to 13. And I know that 6 times 3 is 18. That's too much. 2. 6 goes into 13 2 times. I divided. I need to multiply. 6 times 2 we know is 12. I subtract. Next step. I multiplied 6 times 6 times 2 to get 12. I now subtract. I have 2 minus 3 is 1. 1 minus 1 is nothing. I now have 1. I have 1 left. I bring it on back. Oh, excuse me. I made a mistake. I need to bring down. Guys, do I have anything to bring down here? I do not. There's nothing there. What does that mean? It means I have a remainder. I also can't put 6 into 1 anyways. I have a remainder of 1. 7,453 divided by 6 is 1,242 with a remainder of 1. Standard algorithm, I do. Quick review on the steps to chunk. Okay, obviously partial quotient, not necessarily rules and steps, other than when we're chunking and subtracting. So when I'm chunking, I am multiplying to divide. We'll see all this in a second. I put the factor as my quotient, 6 times a number. I put the factor as a quotient here. I write the product. 6 times a number equals the product. I subtract out to regroup and find a difference to then chunk again. Let's do it. 7,453 divided by 6. I know I'm using partial quotient strategy, so I draw my line. Okay. Gotta chunk and subtract till I can't. When I'm chunking, thinking big numbers, I use numbers I know. I'm looking at numbers I like. I have a 6. I don't see any numbers that I like that go exactly into 6. So I'm going to think big. I'm going to start in the thousands place. That's my biggest place value. Okay, so like we talked about, we can chunk large numbers, numbers we know. And I know when I multiply thousands, I'm just tacking zeros. So in my head, I can think about, can 6 go into 7? 6 times what number is going to give me 7,000 or close to it? Big number. But I know 6 times 1 is going to give me 6, which is close to 7. But also when I'm thinking big, I know that we're in the thousands place. 6 times 1,000 will give me 6,000. That's less than 7,000. I can chunk that out. Let's do that. 6 times 1, 2, 3 zeros. 6 times 1,000. I know when I'm multiplying numbers that are 10, hundreds, thousands, 10,000, I am tacking those zeros because I know 6 times 1 will give me 6. Tack 1, 2, 3 zeros. I chunked. Now I need to subtract. 7,453 minus 6,000. Let's do it. 0 minus 3 is 3. 0 minus 5 is 5. 0 minus 4 is 4. 6 minus 7 is 1. I now have a new whole. I have a new dividend. I am now dividing 6 into 1,453. All right. I need to chunk again. I need to think big. So I know now I can't chunk out another 1,000. That's 6,000. That's way bigger than 1,453. What's another big place value number I know? What about if I'm thinking in hundreds? What if I multiplied 6 times 100? What would that give me? If I multiplied 6 times 100, what would that give me? I know that 6 times 1 is 6. And I know when I'm multiplying tens, hundreds, thousands, I'm just tacking 0. So 6 times 100 will give me 600. Let's chunk that out. Okay, I multiply to divide. I put the factor as the quotient. 6 times 100. 6 times 100 is 600. Let's subtract. 0 minus 3 is 3. 0 minus 5 is 5. Can I subtract 6 from 4? 4 is smaller than 6. If I have 4 and I subtract 6, 1, 2, 3, 4, 5, 6. I don't have 5 and 6 left. I cannot do it. I need to steal 1,000. You steal 1,000, make it 10 hundreds. I can subtract 6 from 14. I can subtract 600 from 1,400. I can subtract 600s from 1,400s. 6 minus 14 is 8. 853 is our new dividend. It is our new regroup number. That is the number we're working with. We chunked out a lot of number to get to 853. Want to think big numbers. I've already chunked 100. Could I chunk another 100 out of there? Could I chunk another 600 out of 853? Absolutely can. Let's do it. I might have wrote too big, guys. We're getting pretty chunky here. Starting to look like Mr. G. There's that joke again. 6 times 100 is going to give me 600. I subtract out. 0 minus 3. 3. 0 minus 5. 5. 6 minus 8 is 2. Okay, now we're starting to cook here. We have a new dividend. We have 253. So I need to think big products, think big numbers. I need to use numbers I know. I need to look at the numbers. I know 6 times 10 is going to give me 60. A lot of 60s go into 253. What if I doubled it? I know that 6 times 10 is going to give me 60 because I'm tacking that 0. So if I doubled my 10 and I went 6 times 20, I know 60 would be doubled. That would be 120. 60 plus 60 is 120. Let's chunk that out. Let's chunk that 20 out. 6 times 20, it's going to give me 120. I subtract out. We're running out of room, guys. I need to get a better whiteboard. 0 minus 3 is 3. 2 minus 5 is 3. 1 minus 2 is 1. Guys, could I chunk out another 20? I know that 6 times 20 is 120. That's less than 133. Let's do that. I chunk again. This is a chunky problem. When we're working with big numbers, things can get chunky. I know 6 times 20 is 120. Gonna have to again write my answer over here. I'll do it again. 133, so you can see it, minus 120. It's going to give me, subtract with me, 0 minus 3 is 3. 2 minus 3 is 1. 1 minus 1 is nothing. I have a new dividend. Can I still chunk? Can I chunk 6 into 13? Can 6 go into 13? So I'm thinking in my brain. 6 times a number equals 13 or something close to it. I know that 6 on its own is 6. That's not close to 13. What about 6 times 2? I could skip count, use a place value chart. I know 6 times 2 is 12. That is very close to 13. If I go another 6, it's going to be too much. I put my 2 up here. Oh my gosh, not much room. 6 times 2 is what? 12. I subtract out. I got 1 left over. Can I still chunk? Can I divide 6 into 1? I absolutely cannot. 1 is a smaller number than 6. I can't think in my brain and be like 6 times a number equals 1 because it's always going to be bigger. That's my next step. I chunked and subtracted till I can't. I need to add my quotients and my remainder. Let's do that. I have 1,000. I always want to start with my bigger numbers first when I'm adding. I have 200s, 100, 200. I have 2 20s and a 2. Let's add it. Get rid of my thought bubble for a second here. 0 plus 0 plus 0 plus 0 plus 0 plus 2 is 2. 0 plus 0 plus 0. 2 plus 2 is 4. 0 plus 1 is 2. 1 plus nothing is 1. I added my quotients, need to add my remainder. Our answer, our quotient, our solution to 7,453 divided by 6 is 1,242, remainder 1. Partial quotient strategy, I do. Moving on to the we do. We're going to stick with partial quotient so I don't have to erase the board. When we're doing our we do, you're working along with me. I'm trying to go slow, give you thought time, as always, if you need to. Pause the video, catch up to where I'm at. Our expression, here is our division problem. We have 9,477 divided by 7. So, I know I need to chunk first. You need to think big numbers, think big products. You need to think with numbers I know, 2s, 5s, 10s, hundreds, thousands. And I need to look at the numbers. I'm looking at these numbers and I see 2 7s. I know that 7 goes into 7s equally. So in my brain, maybe I'm going to start in my ones place. 7 times what number will give me 7? 7 times 1 will give me 7. I know that 7 goes into 7 once equally. So let's chunk it out. 7 times 1 is 7. I forgot my line. Let's make our line if you haven't already done it. Whoopsie. So I subtract. I chunked it out. Now I need to subtract. 7 minus 7 is going to give me nothing. I need to just bring down all my numbers because I'm subtracting nothing. Still looking at the numbers, looking at our new dividend. I have 9,470. I see another 7. Guys, I see another 7, but what place value is it in? What place value is that? That is the tens place. So if I know 7 times 1 equals 7, what is 7 times what is going to give me 70? I know that when I'm working with tens, I just tack zeros. So 10, 7 times 10 will give me 70. Let's chunk it out. 7 times 10 is 70. I subtract out that 70. 0 minus 0 is 0. 7 minus 7 is nothing. Bring down my 4, bring down my 9. I'm subtracting nothing. So, I know now I have a new dividend. 9,400. Thinking big. I'm looking at the numbers. I see no friendly numbers. I see 94. That's not a very friendly number to me. I don't know my 7s that well, maybe. So perhaps I just want to chunk out 1,000. So can 7 go into 9? Can 7 go into 9,000? It absolutely can. Not equally. So in my brain, I know I'm working with the thousands place. So let's chunk out 1,000. I know that 7,000 can go into 9,000. It can be subtracted out. So I'm tacking 3 zeros. So if I have a 7, I tack 1, 2, 3 zeros. That is 7,000. So 7,000 absolutely can go into 9,400. Let's chunk that out. 7 times 1,000 is going to be 7,000. Let's subtract. 0 minus 0 is 0. 0 minus 0 is 0. 0 minus 4 is 4. 7 minus 9. I have 9. I take away 7. 5, 6, 7. 2. So, I now have a new dividend. I have 2,400. I'm thinking big. I know that I can't chunk out another 1,000. 7,000 is bigger, much bigger than 2,400. I can't do that. So, what if I chunked out 100? What if I chunked out 100? 7 times 100 would give me what, guys? What would 7 times 100 give me? Give me 700. 700 can go into 2,400, but I'm going to be chunking a lot. Here's another strategy I want you to use. Just like we've doubled our tens, we can also double our hundreds. So, if 7 times 100 is 700, what is 7 times 200 going to give me? What is 7 times 200 going to give me? Well, I know that when I'm doubling my factor here, I'm doubling 100 to 200, it's going to double my quotient. So 700 plus 700 is going to give me what, guys? 0 plus 0 is 0. 0 plus 0 is 0. 7 plus 7 is 14. 1,400. Can I chunk out 1,400? Absolutely can. Let's do it. I just chunked out 200. I know that 100 would make 7 times 100 makes 700. So I double my 700. 7 times 200 is 1,400. So 200. 7 times 200 is 1,400. I subtract out. Subtract with me. 0 minus 0 is 0. 0 minus 0 is 0. 4 minus 4, 0. I have 4. I take 4 away. 1, 2, 3, 4. Nothing. 1,000 minus 2,000. 1. I now have a new dividend. I have 1,000. So I'm asking myself, can 7 go into these numbers? 7 can go into 1,000. Absolutely can. I know that 7 can't go into 1 evenly. I know that 7 can't go into 10 evenly. But when in doubt, I think big. Let's chunk out another 100. I know that 7 times 100 is 700. Let's chunk that out. 700 is pretty close to 1,000. Let's try that. 7 times 100. 700. I subtract out, running out of space. 0 minus 0 is 0. 0 minus 0 is 0. 7 minus nothing. I can't subtract 7 from nothing. I need to steal from my 1,000. I steal 10 hundreds from my thousands. I make 10 hundreds. 7 minus 10 hundred is going to give me, what's 7 minus 10? I have 10. Take away 7, 5, 6, 7, 3. For the sake of space, hopefully you've left yourself the whole page. I'm going to write my new dividend right here. So, I'm thinking about dividing 7 into 300. We've chunked out quite a bit. I know I'm still working with a big number here. I know I need to divide 7. I know 7 can't go into 3. Can 7 go into 30? It absolutely can. So, in my brain, I'm thinking 7 times what number would give me 30? I could skip count. I could use a place value chart. I know 7 times 3 will give me 21. What's 7 times 4 going to give me? 7 times 4 is going to give me, if I add 7 to 21, that's going to give me 28. That is pretty close. But guys, I am not dividing 7 into 30. I'm dividing 7 into 300. I'm dividing 7 into 300. So 7 times 4 is is 28, excuse me, if 7 times 4 is 28, I can tack a 0. Okay, so if 7 times 4 is 28, 7 times 40 would give me what? 280. 280 is a pretty big number. Can that go into 300? Absolutely can. So I chunk out 40. 7 times 40 is going to give me 280. I chunk it out. Going to get 0 minus 0 is 0. Can I subtract 8 from 0? If I have nothing, can I subtract 8? Cannot. I need to steal. I need to steal 10 tens from my 100. I need to steal 100. I make it 10 tens. 8 tens minus 10 tens is what? 10, take away 8, 5, 6, 7, 8. 2 left over. 2 minus 2, nothing. I now have a new dividend of 20. I need to divide 7 into 20. In my brain, I'm thinking, 7 times what number is going to give me 20? I know 7 times 2 is going to give me 14. And I know 7 times 3 is going to give me 21. 21's too big. 21's bigger than 20. I need to chunk out 14. 2. 7 times 2 is 14. I subtract. 4. Can I subtract 4 from 0 if I have 0? I cannot. I need to steal. 4 minus 10 is 6. 1 minus 1 is nothing. So I have 6 as a new dividend. I chunked a ton to get the 6. Can I divide 7 into 6? 7 times a number equals 6. I'm thinking in my brain, can 7 go into 6? 7 times a number equals 6. I know it can't happen. 6 is smaller than 7. It cannot go into that. 7 times nothing is going to give me a 6. I have a remainder. Next step, I need to add the quotients and the remainders. When I'm adding my quotients, what do I want to do? I want to start with my largest number first. Get rid of my thought bubble. 1,000 plus 200 plus 100 plus a 40, a 10, a 2, and a 1. Let's add them together. 0 plus 0 plus 0 plus 0 plus 0 plus 2 plus 1. So 2 plus 1. All these zeros have no value. 2 plus 1 is 3. I have all zeros. Don't need to bother with them. I have a 4 and a 1. 4 plus 1 is 5. 5 tens. Go to my hundreds. There's a 0 here. Don't have to add it. 2 plus 1 is 3. 1 plus nothing is 1. 1,353. Oh, but don't forget my remainder. Remainder 6. Took my partial quotients. I added them to get a final quotient of 1,353. I added my remainder of 6. So, 9,477 divided by 7 is 1,353. Remainder 6. All right, are we due for standard form? We have 7,842 divided by 8. When I am doing standard form, what is the first thing I need to do, guys? I need to write my steps down. That is the strategy I need to use. Say the steps with me. Ready? Divide, multiply, subtract, bring it on down, and bring it on back. Dividing with standard algorithm. What place value do I always need to start? Need to start in the largest one. In this case, it is in the thousands. So I'm thinking to myself, can 8 go into 7? Can 8 go into 7? 7 times what number will give me, 8 times what number will give me 7? The answer is you can't. 7 is smaller than 8. 8 times a number just can't equal 7. There's no number that 8 times a number will equal 7. So what do I need to do? I'm still dividing. I need to move to the next place value. So I was dividing into my thousands place. 8 could not go into 7,000 equally. So I go to the next place value. Can 8 go into 78? It absolutely can. So in my brain, I'm thinking 8 times a number equals 78. I need to use a strategy. I need to use numbers I know. I need to use a place value chart. I need to think about a number that's going to multiply to get 278 or close to it. I'm going to work with numbers I know. I know that 8 times 5 is 40. Wow, that's like half of 78. I need to make some bigger numbers. I know that 8 times 10 is 80. 80 is really close to 78. It's only 2 ones away. So let's figure out what 8 times 9 is. What's 8 times 9? 8 times 9 is 72. That's pretty close to 78, and it goes in. I'm going to use that. 9. That is the closest number I can get. 8 times 9 is 72. I divided. I multiplied. 8 times 9. I need to subtract. 72 minus 78. 72,000 minus 78. Subtract with me. 2 minus 8. Taking 2 away from 8. 6. 7 minus 7. It's going to be what? Nothing. Subtract. I bring down. I started in my hundreds place, so I now need to bring down my tens. I need to bring it on back. I need to divide. I need to divide 8 into 64, or actually 640. So I'm thinking to myself, what, guys? What am I thinking to myself? I'm thinking 8 times a number equals 64. I need to use a strategy. I need to use a place value chart. I need to think with numbers I know. Maybe I know my 8s really well. I'm going to pretend I don't know my 8s really well. I'm going to think with numbers I know. I know 8 times 5 is 40. That's about 20 away from 64. That's not very close. You know, 8 times 10 is 80. What about, maybe I can meet in the middle somewhere. Meet in the middle between 5 and 10. I'm going to try 8 times 7. 8 times 7 would give me what? 56. That's still less than 64. Let's try 8. 8 times 8 will give me, if I add 8 to 56, 64. Wow, look at that. 8 goes into 64 evenly. 8 times. I divided. I need to multiply. 8 times 8 is what? What did we find out? It is 64. I multiplied. I need to subtract. I subtract out. 4 minus 4 is nothing. 6 minus 6 is nothing. I subtracted. I need to bring on down. I need to bring on down this 2. Something interesting is about to happen here. Need to bring it back. You ask myself, can 8 go into 2? Can 8 go into 2? It cannot. Also, I do not have another place value to bring down. 8 can go into 2 0 times. This is where things get tricky. Okay? Because I don't have another place value to bring down. So 8 can go into 2 0 times. I don't have another place value to regroup with a remainder of 2. We do standard form. This is where you complete work independently or with some support from an adult, whether staff, mom, and dad. When you do that, make sure you have plenty of room on your paper. You then take your paper, take a picture of it, or submit a video of you showing your work for your I Do. Here is your 5 problems for your I Do. 609 divided by 6. 8,147 divided by 9. 3,465 divided by 4. 584 divided by 7. 8,649 divided by 8. Using standard form or partial quotient strategy, do these I Do's. Submit it on Flipgrid. Let's have a great week. You're in to learn, baby.